So in this video, I wanted to sketch a trig function that's got some translations in it. So this translation will mean that we've got x-intercepts, and this will mean that our start and end points are going to be at something other than 0 and 2 pi. And so I'm going to show you how to find axis intercepts and endpoints. But before we go ahead and sketch this, we need to recognise that the transformations in this section of the function aren't in the right form for me to use my standard transformation mapping. So I'm going to rewrite that so that you can see what it is in our normal form. So now we can use our mapping to transform our normal xy coordinates for points on the sine curve to our transformed function. So let's draw up a table of xy coordinates for our standard sine curve, and then we'll transform our points. So this is our table of values for our 5 points on our sine curve over here: 0, 0, pi on 2, 1, pi 0, 3 pi on 2 minus 1, and 2 pi and 0. So these are our points here. So on the top, I'm going to put my transformed x values, and on the bottom, my transformed y values. So let's go ahead and fill in our first transformed x value. So we're going to take our 0 here and substitute it into this equation. Let's just zoom in while we work on this. So we have a half times 0 minus pi on 4, which gives us minus pi on 4. We do the same with pi on 2, and that gives us pi on 4 minus pi on 4, which is equal to 0. Now this jump from one x value to the next x value is all we actually need to determine to be able to sketch our function. The same as from these x values, these were all going up by add pi on 2 plus pi on 2 plus pi on 2. These x values at the top will also increase by the same amount. So to go from minus pi on 4 to 0, we've actually added pi on 4. And so to get to our next one from here, we would add pi on 4. And so we expect our next value to be pi on 4, and our value after that to be 2 pi on 4, which is pi on 2, and then the next one to be 3 pi on 4. So I'll go ahead and I'll do the calculations just to show you that that's what we actually get. So as you can see, a half of pi is pi on 2 minus pi on 4 gets us what we want. A half of 3 pi on 2 gives us 3 pi on 4. Take away pi on 4 is 2 pi on 4. And a half of 2 pi is pi. Take away pi on 4 gets you 3 pi on 4. So once we find the difference between two subsequent x values, we can then continuously add that difference to generate our next numbers, and that will save us some time. So let's now move on and work on our transformed y values. Now I want to just have a quick look back at our graph and look at our y values. So over here, our first value is the median value for our sine curve, then maximum, median, it's the mean value, then minimum, and then mean. And so our pattern goes mean, maximum, mean, minimum, mean, and then the next one will be maximum, mean, minimum. So we have a pattern across here as well. So let's go ahead and work these out by substituting in our y values into the equation. So I've substituted them all in. Let's work them out. 2 times 0 is 0 plus 1 is 1, which means our mean is 1. So all of the means are equal to 1. Let's go back and fill in the next one. So 2 times 1 is 2 plus 1 is 3, so our maximum is 3. So if we had another box at the end, that maximum would be 3. And the other one we need to find is our minimum. So 2 times minus 1 is minus 2 plus 1 is minus 1. So our minimum is minus 1. Now we've got some xy points that we can plot. We're going to plot minus pi on 4 with 1, 0 with 3, 3 pi on 4, 3 pi on 4, pi on 4 with 1, etc., etc. So we're going to need a graph, and then we're going to need to, before we start graphing things, check what our domain is. So let's have a look back at our original question. You can see that the domain of our function is from 0 to pi. And so from our points on our table, I'll just do a quick summary. You can see that the very first point that we have, our x value, is outside of our domain. So our domain actually starts here. And so we need to start plotting our points from here, and we need to continue across until we reach pi. Our domain will finish at pi. And you can see if we've gone up by pi on 4 each time here, so actually we're going to need another point here to fill in the domain. And we can use our constant difference here and our pattern at the bottom to generate our next numbers. So on the top line, adding pi on 4 to 3 pi on 4 gives us pi on the top. And on the bottom, following our pattern, we go 1, 3, 1, minus 1, 1. This should be a 3. And any x value beyond that is outside of the domain. And so these are the points that we're going to sketch. And so I'm going to need to get a graph. So here's our graph, and you'll notice that I've got my x-axis going up by pi on 4, just to make it very simple for myself to sketch. As long as your scale is consistent, you can have whatever value you like sitting at these marks, as long as it's a consistent jump from one to the other. So let me go ahead and plot these points. So our first point is 0, 3. Our second point is pi on 4 and 1. I'll do the rest. And then we can join the dots. And please make sure when you're sketching a graph in the exam that you use a smooth, continuous line. So make sure that when you sketch a graph, sketch in pencil. If you sketch a graph that's made up of all little jagged lines, what you're sketching is a hybrid function. You're not actually sketching the function that you were asked to sketch, and you won't get any marks. So sketch your graphs in a pencil and make your lines smooth and continuous. At the end, I've got some very large dots here, and that's fine. Our end points are included, and please make sure that your end points are clear, whether they are open or closed endpoints in any graph that you sketch. So now we've sketched the graph, let's go back and check what else we need to do. We need to sketch the graph from 0 to pi, which is what we've done. We need to label axis intercepts. Right, so let's go and find our x-axis and y-axis intercepts. Our y-axis intercept is already there, so we can label that. Let's just double check again. We need to label it with coordinates. So let's do that now. And in this case, our end points are in fact some of our main points that we've shifted. If they weren't, you would just take whatever your minimum domain value was, substitute it into your equation to work out your y value, and whatever your maximum domain value was, substitute that into the equation to work out what your y value is for your end points. So let's go ahead now and do x-intercepts. So to find x-intercepts, we let y equal to 0, and that's what I've done here. And we're going to solve this equation for x is an element of 0 to infinity, for x between 0 and infinity. So we're just back to our normal solving of trig equations. So the first thing we do is write this, so sine of something is equal to something else. So if we subtract 1 from both sides and divide by 2, we get sine of 2x plus a half, pi on 2 is equal to minus a half. Now sine is equal to minus a half in the bottom two quadrants, in quadrant 3 and quadrant 4. And so these are the two quadrants we're going to be working in. The other thing we need to find is our reference angle, which is the value of sine, the angle that when you take sine of it gives you positive a half. Okay, so a reference angle, remember, is always what's the angle that gives us this value, but in the positive quadrant. And in our case, it's pi on 6. So our reference angle is pi on 6. Now the next thing that we need to do is to adjust our domain. So we have that x is an element of 0 to pi, and we need to change the x so that it's 2x plus pi on 2. So 2x plus pi on 2. And whatever change we make to x, we have to make the same change to each of the two numbers at the end of our domain. So when we tidy this up, the domain that we're going to use to generate our answers starts at pi on 2 and finishes at 2 pi on 2. So let's go ahead and generate our angles that fit in this domain. So up on our unit circle, if we start at 2 pi, which is at this position on the unit circle, and head in a clockwise direction, we pass pi and come round an extra pi on 6 to get to this point here. And so our first solution is 7 pi on 6. Continuing around the circle from here, this next one that we come across is pi on 6 less than 2 pi. So it's 2 pi minus 6. And then finally we continue past 2 pi and our domain ends at 2 pi plus pi on 2, which is up here. So our whole trip around the domain started at pi on 2 and went round to 2 pi on 2. So we have two solutions. But the solutions that we have are not solutions for x. So now we need to go through the process of solving so that we're just left with x on this side. So the first thing to do, subtract pi on 2 from our answers from both of our answers. So we subtract pi on 2 from both of our answers, and then we'll tidy up, make them have the same denominator and tidy up, which gives us 2x is equal to 4 pi on 6 and 8 pi on 6. So now I'm going to divide both sides by 2 to get rid of the 2 that's multiplying the x. In fact, working with fractions on the other side, it's probably easier instead of dividing by 2 if I times by a half, times everything by a half. And then we'll simplify our answers. And we'll get 4 pi on 12, which when you divide the top and bottom by 4 gives you pi on 3, and 8 pi on 12, which when you divide the top and bottom by 4 gives you 2 pi on 3. So these are our x-intercepts. So now we need to put these x-intercepts onto our graph and then check that we've done everything. So our x-intercepts are pi on 3 and 2 pi on 3. Now it's always good at this point to go back and double check that you've done everything that you need to by reading through the question again. So I've sketched the graph, yes, over a domain of 0 to pi. I've labelled my x-axis intercepts, yeah, and my endpoints with coordinates. Oops, I have to go back and turn my x-intercepts into coordinates. It's always good practice in an exam situation to go back and do what I just did, which I did on purpose, to make sure that you've got everything that you need. Now, if you are asked to write your values as coordinates in the exam, it is really important in the exam that if you're asked for coordinates that you have brackets around them and you have a comma in the middle. It's not enough to just write the two values of the ordinates, you need to have the brackets around them and the comma if you want to get full marks.